Hi all, this lecture will be on probability distributions. We talked about distributions in the previous lecture, part 2 of this week's task, but we will specifically go into probability distributions where we assume we know what the population looks like, and later in the course we will talk about data being sampled from populations like these. To start, we will discuss what is a random variable. It's just like how it sounds. It's a variable to which is assigned the random outcome of an experiment. It can take on different values at different times. If you randomly select a different one, you will get a different value. If it's not a random variable, it's called a fixed quantity, which does not vary. So that's the difference. Okay, so if we look at some examples, okay, so consider the time it takes to drive from Charlotte Airport to Atlanta Airport. Think about this a second. Is it a random variable or a fixed quantity? It's a random variable because the value will vary based on a variety of factors such as traffic conditions, who's driving, what time of day it is, etc. So this is a random variable. But if we consider another example, such as the distance between Charlotte and Airport and Atlanta, what do you think this is, a random variable or a fixed quantity? It's a fixed quantity because the value does not depend on anything. The value is always what it is. So it's not because of who's driving, it's always going to be the same distance. So now consider these examples. Pause the video a minute and see if you can come up with whether these are random variables or fixed quantities. The solutions are on the next slide, but let's go through these with being able to see what the question is. Okay, so the first one, the number of times the letter E appears on a randomly selected page of the newspaper. So this is actually random. The value depends upon the particular page that you choose. If you pick a different page, you get a different value. So for the second one, we say the number of square inches in my computer monitor. This is a fixed quantity because it does not vary. The size does not vary. And for the salary of the President of the United States, this is also a fixed quantity because this is fixed by Congress. It does not depend on the president that is in office. And the last one, the number of dots that land face up if two dice are rolled. This value varies from roll to roll, so this is a random variable. And here are the solutions. Okay. So every numeric random variable has three things: a distribution, a mean, and a standard deviation, in which we went over the definitions of each in the previous lectures. This slide is a review from the previous lecture as well, but we will be looking mainly at discrete random variables right now. And here's an example. We're looking at the number of eggs that are broken in a randomly selected half dozen carton. So we suppose that we know that 35% of all cartons of eggs have none that are broken, and that 25% of all cartons have one that are broken, and etc. Okay, so if we randomly selected a carton of 6 eggs, what is the probability that the carton has more than 2 eggs broken? Think about this for a moment. If we look at the table, more than 2 eggs would be 3, 4, 5, and 6. So you could add the probabilities of all of these values, so here, and this would give us 0.3, which means that 30% of the cartons have more than 2 eggs broken. There's something in your textbook called the rare event rules, which will come up in your homework, so I wanted to mention this right now. The rule of thumb is that any probability less than 0.05 is considered to be unlikely or a rare event. So in the previous example, if we look at the table again, the probability of 5 eggs in a carton being broken was 0.04, which would be a rare event. Okay, there are two requirements to be a probability distribution, but there is actually one other one that is just known. All the values have to be numeric. If not numeric, then it's not a probability distribution. For instance, it can't be blue, brown, any other color, all the categories. It has to be numbers. The two main requirements are that every probability has to be between 0 and 1. And 0 and 1 can be included. That means, in other words, the probability can be 0 or 1 or anything in between. So if you're doing a problem that you get an answer that is less than 0 or greater than 1, you know you have done something wrong. The second requirement is the sum of the probabilities must equal 1. So let's look at some examples. Is this a valid distribution? Just look at the chart for a second. Okay, so we know first all the values are numeric. All of the probabilities are between 0 and 1. So that's two requirements. And then the third requirement is that all of the probabilities must equal 1. So let's sum up these. So from here, 0.2 to 0.4 is 0.6, 0.6 to 0.3 is 0.9, 0.9 to 0.1 plus 0.1 is 1, plus 0.1 is 1.1. So it's not a probability distribution since it does not meet the second requirement. Okay, how about this one? Okay, so all of the values are numeric, but we look at here and we have a negative. So right away we know that this is not a probability distribution. So no. For this example, you are asked to find the missing probability. We know that all these values have to add up to 1 or 100%. So what we could do is just sum the given ones, the probabilities, and subtract by 1. So let's do that. So from 0.25 plus 0.15, it's 0.4. So 0.4 plus 0.2 is 0.6. And 0.6 plus 0.3 is 0.9. So we automatically know 1 minus 0.9. We have to have 0.1 in order for it to be a valid probability distribution. That's right here. And here are quick notes. Quick note, I wanted to say things that come up in your textbook problems that I want to mention because they may be on your homework for the assignments in the textbook. They will list 0 plus as a probability, and what that means is that the probability is greater than 0, but rounds to 0 because it has several decimal places, such like this. But it's easier to say 0 plus, like write 0 plus instead of all the decimal places out. And for you, you can just treat this as the 0 plus as 0. Another thing is when the probabilities are rounded to several decimal places, it is possible that when you sum up the probabilities, they would be just slightly off from 0. As long as it's not more than about like 0.01 in either direction, it's okay. You don't, if it's 0.5, you know you're doing something wrong, or it's not a valid probability distribution. All right, so we might want to find the mean of a discrete probability distribution. And the discrete probability distribution describes the population, which we know from the previous lectures. The symbol for the population mean is mu. It's kind of a weighted mean in a way, since not everything occurs within equal frequencies, and it's calculated as the sum of all x's times p of x. So to write this out, to think about it, we take every x and multiply it by its probability, and then lastly, you sum them all up, sum all the values. We'll look at an example. I have also posted an example video for calculations in Excel, so I would advise you to look at that closely. So going back to the previous example on the number of broken eggs, if we wanted to find the mean, we take every x, and multiply it by its probability. So we have 0 times 0.35, and then the next one is 1.25. This is the probability. And then we take that, right, and we're going to sum all of this x times p of x up, and we get 1.89, which means that in this population of half dozen carton of eggs, we would have a mean number of broken eggs of 1.89. And we also want to know about the standard deviation. Here's the formula, and it looks a little complex, but all we have to do is, once we have found the population mean, mu, we will take every value of x and subtract the population mean from it, and then square that value and multiply it by the probability. And then you just take the square root of that. Here, let's break it down and use another example, or use the previous example again with the eggs. So I take the number of eggs and I subtract, we know that we got our population mean to be 1.89, and then I square that, this whole thing, and times it by the probability. So I get 1.2502, and I do that for all of these. And then I sum this whole column up, and I get 3.9165. Then I take the square root of this, and that gives us our standard deviation. And lastly, the variance. This is just, we know, the square of the standard deviation. So in our egg example, all we have to do is just not take the square root. So we would just take this number when calculating the standard deviation, and we just get this number, like I said. We just don't take the square root. And that concludes, and that's all for this lecture. Look at the example video for how to calculate the standard deviation and mean in Excel. If you have any questions, please let me know, like always.